Good morning, students. So, Unit 1 in special electrical machines. It is all about stepper motor. So you might have studied DC machines and AC machines in electrical machines 1, electrical machines 2. Here in special electrical machines, we are going to see about the machines which you haven't gone through in electrical machines 1 and 2. So here in the Unit 1, we are going to see about stepper motor. In general, the main difference between stepper motor and what are the motors that you have studied is the stepper motor. It moves in discrete angular steps for the input command pulse. Whereas other machines, what you have studied so far, so it might have its continuous rotation. So to achieve this step-by-step movement, the pulses need to be generated, and the phase windings need to be excited in sequence. The most important advantage of using a stepper motor is that the stepper motor will give precise output, precise step angle, even in open loop control itself. So you might have seen many machines need to have closed loop control to get its desired output level. Whereas stepper motor can be controlled in open loop condition itself. So whatever the input command pulse you're going to give, the stepper motor will move accordingly. So that is what the advantage of stepper motor is. In general, the stepper motor machines in the market, it is available as NEMA, NEMA, NEMA 22, 34, 48, 56 like that. So this specification, it mentions the core size, the lamination size, that output size of the machine. Okay. Nowadays, the stepper motor can be even ordered along with the driver circuits, or we can also design specific driver circuits based on the application, but where we are using stepper motors. So in general, stepper motors are classified into three basic categories. One is variable reluctance stepper motor. Another one is permanent magnet stepper motor. The final one is hybrid stepper motor. So most of the machines what we are using will be hybrid in nature. Hybrid stepper motor will be using. So the basic classification between these three types of stepper motors are, so the first one, variable reluctance stepper motor. So the common thing among these three motors are its stator construction. The stator, it is consists of poles over which the phase windings are wounded. So say for example, if there are four poles, then each poles will be independent, discrete, and it will be bounded. So the connections of stepper motor phase windings are monolithic, or sometimes it may be bifilar also. So if it is monofiliar, the meaning is that consider a phase of two ends, A and A dash. Consider A phase which has two ends, A and A dash. If these two ends will be have different set of winding. A will be a separate winding and A dash will be a separate winding. And if these two connections are connected in series opposition, then we used to call it as monofiliar winding. Then what is bifiliar winding? So bifiliar winding will have two set of windings as like A and A dash. So these two windings will be connected magnetically, and there is no electrical connection between A and A dash for bifiliar winding. So this type of connection is rarely used. Mostly we'll be using monofiliar winding in stepper motors. So stator construction is same for all the machines. It has similar laminations as that of a normal AC machine. Table type installations are used, and each phase is discrete, independently wounded. But when it comes to the rotor construction, so these three different stepper motors are unique in nature. If you see, if you are seeing variable reluctance stepper motor, then the rotor will be salient pole in nature. The material used will be soft magnetic material, maybe a ferromagnetic material. Whereas when we come for the permanent magnet type of stepper motor, So the rotor is smooth cylindrical in nature and it consists of permanent magnet. When it comes to hybrid method, hybrid stepper motor, then this hybrid stepper motor will be the combination of both variable reluctance stepper motor and permanent magnet stepper motor. So the shape of hybrid stepper motor rotor is similar to that of variable reluctance stepper motor, and the material used will be permanent magnet. So hope you understand. The shape will be same as that of variable stepper motor, and the material used there will be of permanent magnet nature. So based with this construction, the hybrid motor achieves even better torque, better accuracy, precision, stability is increased in hybrid machines. So it attracts more application compared to the previous two machines. So coming to the different modes of excitation of stepper motor. So there are, in general, there are three basic classification in which the stepper motor can move. One is half step, another one is full step, third one is micro step. So to achieve this half step operation, that is to achieve this full step operation, we need to go for two different methods of excitation. One is one phase on mode or two phase on mode. The meaning is that consider a stepper motor with four phases A, B, C, and D. If I'm exciting one phase at a time, A, then I'll be going for B, then I'll be exciting C, finally D. Like that, I'll be exciting one phase at a time. So this one phase on mode, it gives me full step operation. Even if I'm going for two phase on mode, then I'll be exciting two phases at a time. Say for example, AB, then BC, then CD, then D again DA, then like that AB, BC like that. I'll be exciting two phases at a time. So the rotor will found an intermediate position between these two phases, and again, if we are seeing the step angle, then it will be full step. The full step, the meaning is that, so whatever the step angle, the maximum allowable step angle for the machine design, then we will be getting that. That is the meaning of full step. If you want somewhat reduced step, say for half step, then it will go for a combination of first two modes of excitation. That is, I need to go for alternate one phase and two phase on mode. Alternate one phase and two phase on mode. The meaning is that initially I will be exciting one phase, then I will be exciting the next two phases. Say for example, if I am exciting A phase, then A convert by AB, then B convert by BC, then C convert by CD. Like that, I will be exciting alternatively one phase and two phases. So if I am doing that, I will be getting half step operation. So this reduced step operation is achieved using this. Even if I want to reduce this step angle further, I can go for micro stepping. So micro stepping is achieved such that, as in general, for a stepper motor, for one input command pulse, I will be getting a fixed step angle. That is the meaning. It will move for one step, discrete step, defined by the mode of excitation and the connections, and the number of teeth, number of phases, like that. So if you want to reduce a step further, so instead of applying a complete pulse, let me divide that pulse into different steps. Say for example, for a machine under full step operation, for one command pulse, if I am getting 30-degree displacement, that is 30-degree step angle. If I want to reduce the step angle further, what I need to do is I need to divide the pulse into different discrete steps. If I want to divide, if I divide that single command pulse into 10 equal steps, so instead of getting 30-degree at a strike, I will be dividing the 30-degree into 10 equal displacements, meaning for each step, I will be getting 3 degrees. For each step, I will be getting 3 degrees. So completely for 10 steps, for that is for a single command pulse divided to 10 steps. So for 10 steps, I will be getting that 30-degree. So this will reduce the number of the step angle. That is the result. It will increase the resolution of the machine. The resolution is that, so the number of steps taken by a stepper motor to complete one revolution. It's known as resolution. So if the step angle gets reduced, the resolution will get increased. So how the most advanced machine. So nowadays the design so far that machine is having a resolution of 20,000 steps per revolution. What is 20,000 steps? Then it will be rotating at 360 degree by 20,000. It will be you will be getting 0.018 degrees. So step angle for that stepper motor is 0.018 degree. It is achieved by this micro stepping so far. So coming into that, what are the other ways to reduce this? What are the other ways to reduce step angle? Then you need to increase the number of poles. But if you are increasing the number of poles, the machine inertia, the machine weight, so everything will get increased. And there is a limitation due to design and size. So we cannot increase the number of poles just like that. So instead of increasing number of poles and achieving micro stepping, it is very good to go for step-by-step application of pulses. So if I dividing now each pulse into different steps, I will be getting the corresponding reduced angular step angle. So that is the advantage of using micro stepping. So when comparing these three machines, these three different types of stepper motors, this hybrid stepper motor has its unique construction, which is in nearly some 50 rotor teeth, 48 stator teeth like that. So it will be having a unique construction with number of increased number of teeth. So that is why it is used in many applications. Okay. So in general, as I said earlier, stepper motor, it's a brushless DC motor, so which rotates in discrete angular steps. That is, for each command pulse, it will move for one step angle displacement. The step angle depends upon the number of phases, the number of stator teeth, the number of rotor teeth or poles. Okay. Stepper motor, the major advantage of stepper motor is that it can run even under open loop condition. It can give precise output even under open loop condition. That is what it does not need any specific rotor position sensor or like that to have its operation done. So that is the major advantage of using stepper motor. So in market, the stepper motor is available in different ratings. The name of NEMA 24, 35, 42 like that. So that 42, 24, 35 all represents the cases in the machine. So nowadays the stepper motors are available along with the driver circuits. So inbuilt codings you can turn on, and you can set the mode of operation as single step or that is full step, half step, or micro step, and you can set the direction and the operation done. That is just like that you can do that. Or if you want to code, you can use control codings to control a stepper motor. That will be going through in done through in microprocessor lab also. So this is all about stepper motor. Thank you.